Hello, everyone. Thank you for joining us today for Minitab's Mitigate Future Process Risk with Advanced Modeling, a no-code approach webinar. My name is David Peralta, and I'm an area marketing manager here at Minitab. A few housekeeping notes before we get started. We'll have a Q&A session after this presentation, so please submit any questions you have, and we will do our best to answer them. We recommend viewing this webinar on a laptop or PC for the best results. If you experience a delay or sync issues with the audio and slides, please exit the webinar and rejoin or refresh the page. We will send a copy of the recording following the webinar, so there's no problem if you miss anything or you'd like to review it afterwards. Now I'd like to introduce our presenter, Rob Levency. Rob is a solutions architect at Minitab, matching solutions to the technical needs of large organizations. Rob has more than 25 years of experience in data-driven approaches to improvement in both commercial and government organizations. He has presented at several conferences and published several papers along with a book. We're super excited to have Rob present today's webinar, and with that, I'll hand it over to Rob to begin today's presentation.
Thank you, David. Just to add a little bit, I've been involved in process development for a long time, whether it was in plastics, in metals, in pharmaceuticals, and this is something I wish I've had 20 years ago. And so hopefully this will be an exciting subject for you as well. Well, Minitab's been around for 50 years, and we have really expanded because of feedback from our customers in what we offer. So we have that merge of data-driven and problem solving all integrated together. The areas that we're really talking about here are more in this predictive analytics and machine learning, and it can go into business intelligence, statistical analysis, and up to model development and monitoring as well. So we're kind of in this data-driven side of the equation. Let's talk about some objectives. What are we going to get out of this? Well, organizations need processes that perform well. They want to include the lowest possible risk of non-conforming results, products, and they'd like to have these trends continue throughout a product life cycle. Now, in my experience, I worked for an organization one time, and I really liked their goal. You know, what you're going to do, as you know, products and processes are developed, and then there's that point where they're merging into operations, and sometimes people call those technical transfer, sometimes people will just call those early production. Regardless of the industry, there's that period of time when they start to hit the ground running. And what I really liked in one organization, they had something called 0-70-30. So those launch people, those added resources stayed with an early process until there were 0 defects produced, 70% operational efficiency, maintained for at least 30 days. And that was kind of the bar, and that allowed the development team, the launch team to sign off, and operations would take full ownership. And I thought that was a really cool way to handle that process. It really kept pencil sharp, if you know what you mean. I mean, because the launch people, they want to go on and do another launch. Well, our modern manufacturing really increases their utilization of statistical models to create optimal processes efficiently. And I've seen this in all industries, and I'm happy to say Minitab has been part of this for many, many years, whether it's using just basic statistics or going all the way into design of experiments to really create a good process. But the question is, how can modeling be used to fine-tune new processes? Because think of it, when you're doing development, you're not exposing that process to all possible variations. You're not putting a bunch of different lots of material. It's not being exposed to all the people that are going to be involved with it, all the maybe the environmental type exposure, wear and tear of equipment. So how can we use some modeling techniques to be able to really fine-tune this thing in? Well, we have to have an example. So here's a problem. We have an organization that has a team of engineers, and they've developed a new plastic injection molded component. And they have a unique process, something proprietary, but it's something new. So there's some risk. They know that the component has to be as strong as possible. So during launch, there's this phase that they have called safe launch. And what that is in early production, they're putting increased monitoring and increased quality checks. So they can really be sure that everything going out the door in this new process is meeting all requirements. Well, they're hoping to use the early production data to mitigate the long-term risk of a weak part getting to the customer. So that's what we have. And actually, I used the injection mold sample data from the help screen in Minitab. It's been a little bit changed, but that was kind of the basis of this whole project. Well, let's talk about the data. We're all about data. So this process was developed very thoughtfully using design experiments. So that's probably the highest level of trying to attain a robust process. You're really tuning it in with these randomized, thoughtful experiments to make sure that you have the results that you're looking for. But regardless of the rigor of this design, as I said before, you can't capture all potential sources of variation. It's just not possible. So they develop an early production protocol. And what they're doing in this early production protocol, now you might have some quality people, I might feel people wincing, but bear with me. Well, we've established a control space from our experimental designs. So we theoretically know where we're going to control this process and make good parts. So what we're going to do in this early production protocol is we're going to intentionally make variations within the control space to explore this established space. So they may be doing it a couple different times a shift. And I mean, all that's maybe counterproductive or counterintuitive to some quality folks. Like, no, we want it the optimum, we want to keep it there. But we don't know how this process is going to work long term. So we need to get some of this data to really have an idea of what's going to happen in that space that we think is going to work well. You know, what better time than having increased monitoring and increased quality presence? So the crux of this is we need an effective tool to be able to assess the trends that come from this early production data and use them to fine-tune our control limits. So we know that that long-term risk is as low as possible, and we're going to get our best possible results. And to give you an idea what we're doing in this particular case, we have a really data-driven organization here. And so what they've done is they've collected data, and this is pretty common where, you know, we're collecting maybe a CSV or an Excel sheet where we have data. We may have multiple sources of data. That gets a little challenging. But what they've done to make this better is they've utilized our Connect tool. So what they have is they have a connector that goes out and pulls that data on a regular basis, and they end up getting that data populated automatically. And they can even merge data from multiple sources. So this is a great way for this organization to be able to pull data without really requiring people to write stuff down. It just comes automatically. And now they can just hit their little Minitab button and they can start analyzing. Well, when we talk about modeling, Minitab has a suite of predictive analytics tools. And to be clear, this is an add-on. So if you have regular old Minitab, which is awesome, has a lot of great tools, including cart regression, which is part of regular Minitab. But we now have this suite of more advanced, more precise modeling tools. And, you know, we used to use kind of the standard has been multiple regression, linear regression. That's still a great tool that's been available in the regular Minitab menus for many, many years. But in addition to that, we have these tree-based methods. We have random forests, we have TreeNet, and we have CART. And those are decision tree type models that can be very effective at determining which inputs have effect on our outputs. But within the last couple of months, we've added this really great new tool called MARS. It's multivariate adaptive regression splines. And this is what we're going to use today for our example. So let's think about how people might go about trying to tune in a process. Well, the first thing they might try is, a lot of people have learned linear regression in school. It's something that's been ubiquitous out there. So they might try that. Well, there's some issues with linear regression that we have to be aware of. And the first issue is, what if I have missing values in my data? If I look up top here, I have 1408 in my rows, but there's 299 that have all the data. And when we're talking about especially early production, it's kind of chaotic in some cases. And in my experience, there's maybe some automated data collection that something doesn't work as we thought would work. So we miss some data values. Maybe people forget to write things down. There's various reasons, but I've seen a lot of missing data in early production data. So that's going to happen. It's a reality. And when you're using linear regression, it's only going to use those rows that have all the data, unless you do something like imputation, and that gets a little weird. The other thing is, linear models are highly dependent upon this assumption of normality, that kind of Gaussian bell-shaped curve. And when I look at the probability plots, and we expect our data to follow along this red line here, but I can see that my low and the high values don't behave well, whether I'm using my training data or my test data. So I already know I'm going to have errors when I try to use a linear model because it just doesn't fit. I'm using a screwdriver to pound a nail. Well, what if I have nonlinear influence trends? This is actually more common than people think, especially if you have chemical processes, which plastics can be. Not all patterns are a straight line. And I can definitely see that in my scatter plots. I've got that curvature. I even have some issues with more variance and higher values than I have in low variance. And those are typical problems for linear regression. It's going to create a lot of error in your predictions. And then what if significant interactions are present? I only have so many degrees of freedom in this model. So if I want to throw a bunch of interactions, I better be collecting a lot more data. And that can be an issue for early production. Well, the next stop you might try is tree-based models, right? We have CART, we have random forests, we have TreeNet. The pros of those models, there's no distribution-based assumption. So it doesn't matter what shape your data is, it's going to work. Also, even if you have some cells missing, it's going to use all your rows to create your model. So, you're not going to be missing some maybe important information in some of those rows that have some missing values. It's going to utilize everything. And these models handle interactions well. If there's interactions embedded in your among your inputs, it's adjusted and it's handled quite well. Well, there's limitations as well. There's no coefficients available to quantify the influence of factors. So I can tell which factors tend to split my average results, but it's hard to tell other than looking at how many splits that a factor is responsible for. I don't have an equation to really quantify that influence. These tools don't necessarily capture nonlinear trends, so that's another issue. And there's some limited capacity to include all available predictors. So, a little bit of limitation there. Well, now we have MARS. This is what we're going to really be utilizing today. The great thing about MARS, it's an algorithm that identifies complex behavior of inputs. And we can see in this example, it really is kind of a collection of many functions that are linear in nature, these little lines, but it fits a complex shape very well. So that machine learning that's utilized with Mars identifies the optimum number of base functions. So these mini functions that get totaled together to make the Mars. Interactions are captured, and I can even get quantification of those interactions with coefficients. There's great predictive power, and I have this coefficient-based model, so I can have an idea of how much influence each base function has on the total. And there's no distribution-based assumptions, and I can have some missing data out there. So these have really a lot of advantages over linear regression, and they have advantages over tree models for the purposes we're going to be using today. So let's take a look at it. Here's our data that we've pulled over from Connect, and we can see that we've simplified this a little bit. In our regular data, we have many predictors, but for the purposes of the timing of this webinar, I've simplified it. We have machine, injection pressure, injection temperature, cooling temperature. We have a melt zone, mold temperature, and our end item, our strength. So this predictive analytics module, if you don't have the add-on, all of these things will be gray. So you'll see them that they're out there, but you need to get with your account executive and figure out what it takes for your organization to bring this in. But I can see that I have Mars regression. Now, the one thing that I wanted to point out is that don't let the dialog box fool you. This is a very precise technique, very precise algorithm, works great with complex data. But as I look at this dialog box, I'm like, well, gosh, this is super simple. Hats off to our development team to make this so easy for folks to use. I don't have to go through textbooks and go through a bunch of code and debug and try to figure out how to make this work. All I know is what is my response, in this case, strength. What are my continuous predictors? So I've pulled injection pressure through mold temperature. And what are my categorical predictors? Now you can run this as is, but there are a few adjustments out there. I'm going to just cover a couple. You can identify if you want interactions included. For this example, I'm just doing this additive model just for simplicity, but you can allow interactions. And the other thing that might be something that you would want to adjust based on your data is your validation method. So you can either have no validation, but you risk overfitting. Or if you have a fair amount of data, kind of a long data set, as opposed to how many predictors you have, you could probably do validation with the test set. And that's where you're going to build a model with maybe 70, 75% of the data, hold back 25 to 30% to test it to see how well it works. Or in this case, I have a relatively short data set. K-fold cross-validation works quite well. Behind the scenes, there's a subset of some folds that get averaged, and that will create my validation set to test the predictability of the model that I've built. And if ever you get stuck on any of this, you can always go to the help screen, and Minitab Help is going to take you right to the spot that's most likely going to answer your questions. So please utilize that help screen. It's very helpful. And there's some other tuning parameters, but I'm going to just run it in the default for time's sake. And let's see what we get. So what happened is the Mars algorithm looked at 30 base functions to fit that adaptive spline. I'm going to skip to the down, and we'll come back to this in a second. So what we found is the fit is around 70%. So my predicted side, my test side's about 69%, training side's about 75%. I always like it when these are fairly close to each other. That means my model's pretty stable. And so roughly about 70% fit. That's pretty good. So 70% of the variation in strength can be affected or can be explained by the model. And if I would have used more of my predictors, I probably could have made that a little bit better, but I'm trying to focus on the big hitters here. The next step is looking at how did those inputs affect my output. So I can see that injection pressure, that has the biggest effect. So as I change injection pressure, it has the most effect on strength. Mold temperature, machine, cooling temperature, and melt temperature are my next group. Well, let's talk about interpretation, and we'll get back into the guts of the model a little bit more. When I look at scatter plot, generally these have a linear pattern. Yeah, you could argue there's some spread about that. Well, that's why I have a 70% fit and not a 90% fit. But I think for early production, that's pretty good. I'll take 70%. So how are we going to use this? Well, now I can look and see there is a nonlinear pattern in how injection pressure affects strength. And remember, I was already knowing what I thought my control space was going to be, what my limits are going to be. And I was varying within that space. But now what I've been able to flush out is, oh, well, if I'm in this lower range, which would be, maybe let's say less than 130, I'm going to have strength decline and then maybe come back up. So now I can talk amongst my cross-functional group and say, I think our best bet is maybe reducing our space here to maybe 125 to 150. We're going to have much better results in this area than we're going to have down in this area. What other patterns do I see? Well, mold temperature. Well, one of the things I can see here is that I have an optimum that's kind of right around 300 degrees. Well, this is very interesting to me because think about it this way. For me to get higher mold temperatures that before we've identified we're okay, I'm going to have to put more and more energy into that heating element. Well, more and more energy means higher and higher cost. So not only do I have the ability to identify an optimal area for long-term quality, reducing risk, I also identify that, hey, this area down here, which is going to be a lower energy than what we thought we needed, is going to be my optimum area. So lower cost process, longer term, we have mitigated risks. That's a win-win. And sure enough, I have a linear trend in cooling temp. The higher the cooling temperature, the better. We may want to restrict into somewhere in this upper zone so I get the best possible chance of making a strong part. And then this one is very interesting to me because remember, we had this linear model, and I'll show you in a minute, but I can see here I have this whole big flat of high strength parts. And as long as I don't go above, let's say around 215 degrees in this melt zone, I'm going to have strong parts, the highest strength. So once again, low cost, high quality in this particular zone. So in just these plots, I've now learned a ton about my process. And by the way, if we look at this in comparison to our linear model, remember we said we might hit a linear model first. So let's put that in here and split it. When I look at fit, the best fit I get from a prediction standpoint is about 48%. My Mars hits at 68%. So fit is much better. And when I look at my plots, I can see that, oh, I assumed this linear pattern of injection, but it's highly nonlinear. So this may have really misled me on where my best areas are for operating, like especially when I look at mold temp, It's telling me, oh yeah, go the higher the better. But that's not what Mars is finding as we get this more precise model in place. So very interesting how I can get these fine-tuned elements. And lastly, we'll get into a little bit of the detail. So we can see what's happened is we have all these base functions, but there is a way from a machine learning standpoint, there's an optimal number of base functions that was identified. In this particular case, it was 9. As I go above 9, I'm not going to get a whole lot better. And I get this beautiful equation that I can now use to predict. So I've actually added that to my data set by using my button below. Oops. And I can now get all my predicted fits. Or if I wanted to, and I wanted to try out some scenarios, I can just go to the bottom and I can plug in some individual values and I can get some predictions on what I can expect, which is even better for fine-tuning some possible scenarios on what I might want to have as a new control space. So let's summarize a little bit. Now, I'm not going to get into the nitty-gritty details. We have some webcasts that we've done during Predictive Analytics Week, and we have some other things out there, but very simplified. This is more of an applied version of this tool, but what Mars is doing is it's creating this base function first that fits the most simple function aligned to the data. The next step is it's going to find a predictor that's going to create the greatest improvement in fit. So now you can see we kind of created this hinge point where I have 2 linear models that work better than just the single linear model at fitting the data. And then from my third base function up to wherever I end up, we're going to continue to add base functions to find those predictors that improve the fit the most. And then once I get to that point, like in our example, we had 30 base functions, then stepwise backwards methods are utilized to optimize where am I getting the best information. And I can even see in this plot, I theoretically could go down a few pegs here, maybe go to around 5 or 4 base functions and not lose a whole lot of fit if I wanted to simplify. And like I showed you, we have this great equation. So you can utilize that for predictions, and it actually has the ability to have coefficients for each one of those base functions. So that is very flexible to be able, excuse me, to make some predictions. And once again, we can utilize this particular technique to back off a little bit if we need to. So we can have fewer base functions and explain almost as well as maybe what we have originally. So I know I'm going to leave some points for questions here, but and we can reiterate on some points as well. But early production is the best time to stress test a new process. We used to do this later in my experience, and it paid huge benefits just because, like I said, we don't know what's going to be the effect of new lots into this process. So it's very important. Data collection for that new process when you're first getting it into production really should include intentional variation within that defined control space, your control limits that you put out in your manufacturing orders. Now, there have been techniques in the past. I remember we used to use EVOP, which were kind of a way to pivot into that space and try to, optimize. But I think this is a more eloquent way of fine-tuning a process and trying to find areas that are going to limit your risk. Mars is an excellent no-code solution to flush out those nonlinear trends. Remember, too, that when you do your data collection, you don't want to just do highs and lows because it's hard to find a nonlinear trend in highs and lows. So, one way to do this is maybe set this up in kind of a DOE sampling plan and maybe sample like it's a space filling design or if it's a response surface design, because you would like to get differing segments within your limits that you have in your inputs. And that's going to really help flush out those nonlinear trends that may be present. Once you have that control space where you expect to operate this process, and you have it optimized using predictive analytics, you're going to greatly eliminate long-term risk. One of the biggest compliments that was ever paid to me is in a prior life, I was a research fellow, really helping R&D organization with new products. This happened to be in the pharma space and consumer products. And our executive vice president of R&D once in a meeting said, your group are the night seeing goggles of our organization. And I was like, wow, what do you mean? He said, well, you have tools that can see things that we can't. And I see that in predictive analytics. It allows you to flush out patterns and trends that are not immediately available using other means. So very important. And I'm going to throw a bonus out there. So I want you to think about this. So we already know we can fine tune a process and we can mitigate long-term risk. Well, even in early production, we may not have all sources of variation identified. There's things that can happen in a mature process, especially as we've had supply chain disruptions. You may have raw materials where you'll get certifications in, and now you have to go to another source, and those chemical and physical values change a little bit. Well, what if you could take that stream of data from those certifications, from those identifiers of those inputs, and you could now take this Mars prediction and you could get ongoing predictions before you ever run the process. So you could take those certifications, those values that might happen or that are going to happen in your later lots, and you can actually do maybe predictive SPC, or you could do some other tool. And when you see an unstable pattern that's emerging before you even run the process, you can act upon it and mitigate it by using those levers that you know in the model. There's a blog that was out late in last fall, if you go out into the Minitab website, where we have some refining companies that are examining this possibility as well. And they're saving millions of dollars in engineering efforts. As they're seeing differences come in the raw materials, they're able to react before they even run it through their complex process. So that's exciting. I think those technological improvements are really exciting. Well, hopefully you've enjoyed this presentation, and we're going to be getting into some questions and some discussion. But before we do, you need to know some resources that are available. Our website has a whole link for our predictive analytics and explains Mars. So if you want to know a little bit more about Mars, it's out there in the Minitab website. Also, please utilize the online help information. There's a lot of information under predictive analytics. You can see a lot of information on Mars, how to do the results, some examples, how to interpret those results. Very good information. It's been well put together. And we recently had a predictive analytics week. There's videos that I'm sure will be forthcoming and other resources. So I highly suggest that you take advantage of those resources as well, because you can learn a little bit more, maybe the technical details than what I shared in this application-focused example today. So you've got this idea of fine-tuning processes using Mars. You have all the resources. You've seen an example. So for all of you who've signed up for this webinar, I must tell you, you are now one of us. So get out there, get involved, learn more about it than what I can tell, because I think it's an exciting new advancement that we've been able to offer our customers. And at this point, I want to be able to answer some questions and maybe start a discussion here.
Yeah, thank you so much, Rob. And now we're gonna get started on our Q&A session. But before we do that, we all hope you enjoyed the presentation. And I'll give you guys some time to submit any questions you like answered today in the Q&A box below. We also ask that you provide your valuable feedback by taking the survey accessible from the pink survey box at the bottom of this window. And we received a lot of great questions. Rob, I'm going to start with Donald here. He's asking, is this Mars data from a DOE or production data? Cooling temps at 25 and 45 make it look like a DOE. Large ranges on lots of the inputs make me think it's a DOE or the process is not in control/stable.
Oh, very astute. This was example data, so I tried to get it as close to looking like early production data, but you do see there are some maybe larger changes in that than what you might see in a control space. So it's modeling data that has been, a little bit adulterated, or if you will, I guess that's a bad term, but I kind of played around with it to try to make it look a little more like early production data. So very astute, but that early production data is highly prized by organizations, and it's extremely difficult to ask somebody to share their highly proprietary early production data with us so we can create an example. So, but if anybody has that stuff out there or sources for that, that can be tough to come by, and let me know, because we could try it with some other data.
Great, thanks, Rob. We have another question from Pierre. How is multicollinearity handled?
So you do have those interaction terms. That's one that I might need to ask, because I know, like in the tree-based models, when you have similar influences, that suggests that you may have multicollinearity. And then what I typically do, will just use the multivariate stats to flush that out and see, do I have that occurring in my data? So that's a question that I'm going to take back and ask of my technical experts. Great question.
We have a question here from Omar. How is overfitting handled in Mars? Is the difference between the training and test enough to use as an assessment for overfitting?
Yeah, generally, and also looking at the patterns of like residuals as well. But generally, using that validation set is going to help. What folks sometimes will do is, if they're very concerned about overfitting, they might try different validation schemes. So maybe I might try the K-fold validation scheme, see how that turns out. I might try some differing holdback methods. I might try 30%, 25%, 20%, and see what the net effect is. If that fit doesn't change all that much, then you have, probably a pretty stable scenario. If you have great differences in the fit, then I would say you probably want to try to use as much data as you can for your validation set to try to minimize that.
Great, thank you, Rob. We have a question from Miguel. What if I have macro data of more than 10 million lines?
Well, keep in mind that Minitab works in random access memory unless you're using the cloud version. If you're using the cloud version, you have much more computing power, because the algorithms are being run in a cloud-based generation. I just got some information from TechOps that I think we can go, I don't remember what the total size was, but it was something like 4,000 variables, and There were millions of rows, but I don't remember. I think what's going to happen is the downside of using some of that really, really big data is, it's kind of like what we have in even linear regression. Everything starts to look significant. So there's pros and cons of using very, very big data. I remember we were using some data on a probe in a granulator, and we had millions of rows of data. And we actually subset it down significantly because it was taking data like every second or something like that, or even faster than that. But the physical changes weren't happening anywhere near that rate. So we were just getting blinded by so much data that we ended up subsetting to get a more clean perspective. It depends on your application, but it will work on very large data sets. It just takes a little more computing power to be able to get those results.
Now we have time for 2 more questions. So here's one from Matthew. How is Mars different than piecewise regression?
That is a great question. I think it's similar in that, you're using these base functions, and then you are, kind of creating this additive total spline. That one I'm also going to take back to my technical expert as well. I would say there's some similarities, but exactly how those algorithms differ, I need to do a little checking on that.
Sounds good, Rob. And then the last question here, and this has been asked a couple of times. I'm interested in acquiring the predictive analytics tools. Who can get, or how can I get the add-on?
So if you can go out and you can contact us through the website. If you don't know who your account executive is, put in a request. That request will be sorted to the correct person, and they can get in touch and determine your needs and determine, how many you need, that kind of thing. It is an add-on to regular Minitab. And there are, depending on the people that are involved, there's, different types of discounts. The more that you get, the better the price becomes. That's outside of my bailiwick, but if you just contact us with your interest, we even call tech support. They can get that information to you, and check out on the website where we go into predictive analytics. There's also some links to be able to pursue that and show your interest, and we can get in touch and make that happen.
Great. Thank you so much, Rob. And thank you, everybody, for submitting your questions. I know we don't have enough time to answer all of them, but we really do appreciate it. And now to close this webinar, I'd like to share some information for those who may not be as familiar with Minitab. For 50 years, Minitab has helped companies spot trends, solve problems, and discover valuable insights into their data. In the webinar today, you saw Minitab's new predictive analytics tool, Mars. Some of our other solutions include Minitab Engage, Minitab Connect, Minitab Workspace, Minitab Model Ops, Real-Time SPC, Education Hub, and SPM. We also offer training, statistical consulting, and technical support services. Thank you all for attending today, and we really hope you found this webinar valuable. And we wish you all a great rest of your day. And we're going to keep the webcast going to allow the audience to fill out the survey. And we really appreciate it. Thank you.